Okay, we're going to learn how to write some functions today. First, we have to determine whether the relationship between the x and the y values is a function. So again, no repeating x values here. For every x value, there's one y value. And now we have to figure out how to write a function. I'm going to tell you right up front. Your functions are going to be written y is equal to something happening with the x. So when we look at this, let's look at this and say y is equal to something with the x. So now let's go back and figure out, what can I do with this x to turn it into a 1? Well, I could take it and subtract 4. That would be one option. I could take it and divide by 5. That would be another option. Can you think of anything else? So basically we're going to add, subtract, multiply, or divide. Okay. All right. Now let's take these two situations and apply it to the next x value. If I take the next x value, which is 10, and subtract 4, does that give me 2? No, so that one didn't work. If I take 10 and then I divide it by 5, does that give me 2? Yes, that one works. Let's check it with this one. If I take 15 and divide it by 5, do I get 3? Yes. Here, if I take 20 and divide it by 5, do I get 4? Yes. So I took whatever x value I had and I divided it by 5. And it is just that easy. Okay? Let's take a look at this one. Again, what can you do to 1 to turn it into 3? Again, you have to add, subtract, multiply, or divide. So here I can take 1 and I can add 2, or I can take 1 and I can multiply it by 3. Okay? So now let's move over and try this one. If I take 2 and add 2, does it give me 6? No, it doesn't. If I take 2 times 3, does it give me 6? Yes, let's try this one. 3 times 3 gives me 9. 4 times 3 gives me 12. What did I do to the x value each time? Multiplied it by 3. That's how we take something and write an equation for it. The input of the function is the independent variable. The output, or the answer of the function, is your dependent variable. So you can figure this out by making a depend statement. Whatever the situation is, see if you can word it as this depends on this. So in this example, I'm asking you to identify the dependent and the independent variables in the situation. So we read, a painter must measure a room before deciding how much paint to buy. Well, what are the variables? I would say how much paint, and measuring would give us some kind of dimensions. So ask yourself a depend question. Do the measurements depend on the amount of paint, or does the amount of paint depend on the measurements? Okay, let's take a look here. The amount of paint depends on the measurements. That means the amount of paint is your dependent variable, and the measurement of the room is your independent variable. Try this one. Again, your dependent statement would be the height of a candle depends on the number of hours that it burns. There are several different ways to describe variables of a function. The independent variable, we also say that's our x values. In math, we use the word domain. We say it's the input, okay, or just x. For dependent variable, we can say it's the y values. It is the range. It is the output. And we have this funky little symbol here, which takes the place of y. And this is called function notation. Okay? So when you say this, the dependent variable is a function of. It means it depends on, and it is the result of some kind of function happening to the independent variable. So here I have it written in words. Y is a function of x. So y is equal to some kind of function. That's where that f comes from. And then the variable, your independent variable, goes here. So we can say y is equal to f of x. Y and f of x are the same thing. If your function is written like this, y equals 2x plus 3, then you can also write it f of x is equal to 2x plus 3. You see the y and the f of x have simply taken the place of each other. The difference is if you use this function notation, you are making a statement from the very beginning that it is a function. This very well could be just a relation, which is just some kind of connection between the two. But when you use the f of x, you are stating that it is a function. So here's your function machine. And again, this is your input, your x values, your domain, your independent variable. This is your output, your y values, your range, your dependent values. And again, what happens is this goes inside here. What goes in, something happens in here, an answer comes out. If you have it written like this, it's the same thing, it's just that part goes in there. Nothing changes. This took the place of the y. So something goes in, something happens to it in there, something comes out. So try another one here. Okay? The fee a math tutor charges depends on the number of hours. Okay? So we can actually go ahead and write a function for this. Okay? Either f of h or y. Now we're going to actually use it. So if I give you something in function notation and I ask you to find f of x, I'm asking you to evaluate this when x is 7 and when x is negative 4. So what you're going to do is you're going to substitute them in. Alright, so you're going to take the equation, you're going to substitute in. You just substitute the value in place of the x. So for the first one, your x value is 7. You put it in here, you work it out, there's your value. So f of 7, see how it's written here? F, the function of this value when I put in a 7, is 23. On this one, we're going to put in a negative 4. So the function of the value when I put in a negative 4 is negative 10. Again, remember, this goes in, you do something with it in here, out comes an answer. It's just that easy. So I want you to try this one. Okay, now, this one, instead of putting a function machine over on the side, I put what's called an H chart. It's just like a T chart, except I give you that middle section there so that you can do your work. So when I put in a 600, this is the work that I did. So this is what was inside the function machine before. And so 1/3 of 600 is 200 plus 2 is 202. This is what went in, this is what came out. The same thing with the negative 12. 1/3 of negative 12 is negative 4. Negative 4 plus 2 is negative 2. All right? When you use a function for a real world situation, you might not be able to use every single number. It might not be reasonable for your domain and your range. So for instance, you might have to adjust that. If a number represents the length of an object, then it means it can't be negative. If you're talking about how many people, that would be a whole number. So I wouldn't be able to use fractions or decimals. Here's an example. The setting on a space heater are the whole numbers from 0 to 3. So right there, they're telling you when you choose x values, you can only use the whole numbers. The total number of watts used for each setting is 500 times the setting number. Write a function to describe this. So you might want to do this. Now, since this is a function, I'm going to write it in function notation. I'm going to say f of x instead of my y is equal to, all right, ready? 500 times x. But then it asks me to find a reasonable domain and range. So my domain would be my x values. Well, it says it has to be a whole number from 0 to 3. So that's going to be 0, 1, 2, and 3. That means the range would be, well, what's 500 times 0? 0. What's 500 times 1? 500. 500 times 2? 1,000. And 500 times 3? 1,500. So in this case, my domain and range are different. And that's it.